the laser can be seen.
Okay, please.
Okay, sure. Thank you very much for the opportunity to present my paper here. My name is Deborah. I will present the research about knowledge graph construction using information extraction of Indonesia cosmetic product text in Bahasa Indonesia. In this presentation, I will divide the explanation into 4 sections. The first one is the problem. The second one is the proposed system. The third one is the results. And the last one is the conclusion. So the research are using knowledge graph, which contains entities and relations as the knowledge represented in a graph data structure. And the knowledge graph itself provides machine understandable resources, as mentioned by Ataye. Knowledge graph describes real-world entity and its relations defined in schemas, and then it also can be represented using a resource description framework. Because the knowledge graph is a structured data, we need and the source data is from unstructured data. We need information extraction that is very interconnected strongly with knowledge graph topic. E-commerce have a lot of data product that we can use as the source data to create their own knowledge graph. Even Alibaba has already their own knowledge graph, Alimi, that captures user problems, points of interest, and item information, even the relations between them in the knowledge graph. While the information extraction becomes one of the topic in this research, it needs specific tasks and specific source of data, and therefore we need a lot of data for training a model. In Josephine and Purwarianti research, they need 8,400 data as training data to build a model using the LSTM architecture. And so, because there is one of technology that we are going to use, which is transfer learning, as the extraction of knowledge from source tasks and to use the knowledge for target tasks. This transfer learning permits that we can use a low resource of data to make a model into a specific domain, which is the e-commerce. Amazon has been working to develop their own product knowledge to focus on extracting knowledge from text product and apply it into their business. And also the Alimi, as mentioned before. And so we are moving to the second part, which is the proposed system. This is the framework that we are adopting. The first one is they consist of some modules. This is the part where the product text should be. And then in the framework itself, there are 5 modules: entity mapping, co-reference resolution, triple extraction, triple integration, and predicate mapping. And for our research, we only use some of these modules because of the type of the product text itself. This is the example of the data set that I use. If you can see here, this is the brand, this is the product name, this is the size of the product, this is the texture, and this is the usage of the product. If you notice, there is no relations or noun in or verb in here, so that's why we need more product ontology to provide the relations between the entities that are mentioned before to the knowledge graph. in this research, I adapt from schema or schema. We use 3 entity, that is product, brand, and organization. For each entity, there are properties such as name, size, variant, usage, and texture for the product, and it relates to the entity brand which has a brand which has the name. The proposed system architecture for this research can be seen as in the screen. The product text will be extracted. The product text name entity will be extracted using the model, and then the extracted model will be mapped. The entities will be mapped, and it will be integrated with the ontologies definition into the and then we produce it into RDF format and we store it as a knowledge graph. As you can see, this is the part of the information extraction. The text product that is being used will be split into 2 datasets, to train and to test. The train dataset will be used for training the model, and the test dataset will be used to evaluate the experiment. In this part, we also use some libraries. The first one we use scikit-learn, and for the training we use Keras, Hugging Face, and PyTorch. For the metric scoring, we use an open source project called SecEval. And then the next one, in the training itself, we will be using Hugging Face with 2 models, Ambert and Excellent Roberta. These 2 models are multilingual model. The reason we use this model is because in the product text consists of not only Indonesia, Bahasa Indonesia, but also English. Therefore, we use multilingual model and we'll be evaluating which architecture is the best one for this domain. The train dataset, as you can see, is split into 2 training and validation, and then the training will be go to the fine-tuning training. So we'll be using a fine-tuning approach, transfer learning, which tune the last part of the models so it can be matched with the label list. And in this part, the labeled product description will be extracted into phrase, and then it will be mapped into the similar into one entities, and then for each document, and then we can by using ontologies limitation. For example, one product only has one brand. We also limit the entities, and then we create a URI, and then we also map across documents. This is wrapped into one module called mapper. And for the entity mapping, we'll be using text similarity checker module that's using subset translation and text similarity algorithm. This is based on the data itself, because there are a lot of data that are subset from each other, and there is some data that is also has the same semantic but from different bahasa in language, and then we'll be using also the text similarity algorithm using an open source project too. As for the triple integration, the entity that is mapped will be constructed using ontology, and we'll be building we'll connect the entities with relations based on ontology, and also we'll add an organization brand rules for this entity. to make it more clearer, let's see an example from the proposed system architecture. In information extraction, this is the example of the product text. The product text documents are as in here, and then the information extraction will extract the entity into labeled classes. There we're using bio notation, which means B means begin, I for inside, and O for other. So in this case, because Sariayu is the B brand, color is the B product name, trend is I product name, and so on. The extraction information will be mapped as explained before in entity mapping, where we will be mapping the entities into for in each documents and for cross documents. This is the example for in each documents. This is mapped to itself because there are no because it is only it is already it has no similarity in the checking, and this for this example it is mapped the dual lip color price is mapped to this one to color trend 2016 dual lip color using subset approach. And for the liquid and Chair is the translation using the translation approach. And the last step in triple integration and producing the LDF format, we're going to the entities that are extracted from the information extraction.
Deborah, 1 more minute.
Okay, sure, sir. Are these entities, and we connect it based on the ontologies into triples. And the last thing is we map the triples into LDF format. As for the results, we use as present in here the train and the test, and we split into 4 scenario, where the scenario are as in here. And then this is the result. The first scenario, as mentioned here, are the products that are in the brand, that the brand is in the training data set and different from different platform. The second one is the from different brand and from different platform. For the third scenario is the same brand but different platform, and the fourth scenario is for different brand and different same platform. And as seen in the table, the XLMR performs better, a lot of better than the Embed, and one of the most important part is the brand prediction. The XLMR can predict more better than the Embed.
The time is up.
Okay, sure, sir.
Okay, thank you very much, Deborah. Time is up. So we invite all participants to ask the questions. Is there any questions to this paper? Okay, I would like to ask, in your features, in your case, the product was cosmetic, right? So what if we implement to other products? So what kind of efforts should we do?
May I clarify the question? Does the question means different domains or different products?
Different products.
So because the models is quite robust for different brand, I think even though that is a very different brand, we can still use the same model, and then for the construction part is the same.
Okay, thank you very much. We have one questions for participant. So Parila again, please, Parila.
Okay, thank you, Pak Rizal. Okay, thank you, Deborah, for your nice presentation. Yeah. Okay, I have questions regarding to your research. Okay, you said that the knowledge graph map that you created, yeah, in your research, yeah, the performance has the precision 0.94. Yeah. My question is that why you use only precision? Yeah. Why you don't use recall, for example? Yeah. Why you choose precision? Why? Because you know that the precision can be very high, yeah, but recall can be very low. We can always increase precision, but make recall become lower, yeah, or vice versa, yeah. We can make the recall become very high, but the precision become very low, like that. So it is quite tricky, yeah, about recall and precision, yeah. So in my research, actually my field is information retrieval. We cannot just judge, yeah, the quality of the knowledge graph, yeah, just by using precision, yeah, but also it has to use what's recall, yeah, like that. Okay, my second question is that, yeah, what is the usefulness of your knowledge graph, yeah, knowledge graph, yeah, like that. Have you already tested the usefulness of this knowledge graph? Yeah, the application, yeah, like that. Yeah. Okay, that's all my question. Thank you.
Thank you.
Pak Rizal.
So for the first question is we use the precision as the metrics for knowledge graph mapping because it's actually a manual checking between the mapping. So we check whether the mapping is correct or not, and it actually wouldn't map into a false negative because of using the approaches, and yeah, it's more of the entity mapping, sir, not the knowledge graph itself. So maybe to elaborate more, like in here, the dual lip color is mapped into color trend 2016 dual lip color, and this is it's more like it's better. So that's why we are using precision, because it won't reach false negative. And then for the usefulness, I haven't tried the usefulness into an application or user, but the knowledge graph itself currently are used to not currently. I mean, we can utilize this for searching, for providing for searching. That's one of the usefulness of knowledge graph. And even we can also see a visualization of the products in the knowledge graph.
Okay, thank you.